In this video, I am going to create a partial fraction of the given expression, which is 3x plus 2 divided by x minus 1 whole cube. Now, in the denominator, I have x minus 1 whole cube. If you have denominator of this structure, something like x plus, let's say, a to the power k. K is some positive integer. In this case, we are assuming it to be greater than 1. Then you do the following. So you're gonna rewrite it as 3x plus 2 divided by x minus 1 whole cube, okay? And you're gonna rewrite it as a over x minus 1 plus b over x minus 1 whole square plus c over x minus 1 whole cube. So you see the structure. You go x minus 1 whole square, x minus 1 whole cube. What if we had x minus 1 to the power 4? In that case, we will just write another expression, right? Plus d divided by x minus 1 to the power 4. So you get the idea. Now we are going to multiply both sides of this equation by x minus 1 whole cube. 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 On the left, this and this is going to cancel out. That's going to give you 3x plus 2. And on the right, you're going to have a times x minus 1 goes into x minus 1 cube, x minus 1 square time. So it's going to be x minus 1 whole square plus b times, again, you see, you get the idea. It's going to be x minus 1 plus c times 1 because that cancels out. Now, if I rewrite it, I get 3x plus 2 is equal to a times x square minus 2x plus 1. I'm just simplifying x minus 1 whole square plus b times x minus 1 plus c. Now 3x plus 2, if I simplify the right side, I get ax square minus 2a times x plus a. Then use the distributive property. B times x is bx minus b plus c. 3x plus 2 is equal to ax square plus negative 2a plus b times x. So I'm combining the like terms plus the constant terms a, negative b and c, a, negative b plus c. Now this is an equation. An equation says that left hand side must be equal to right hand side. In this case, we are dealing with polynomials. So coefficient of the corresponding terms in the left side should be equal to coefficient of the corresponding terms on the right side. So let's go ahead and do it. I'm going to add a new term, 0 times x square. It's as if I'm adding a 0 to the left hand side, which should not make any difference in the equation. Why did I do that? So that I can compare apples to apples. So the coefficient of the square term on the left must be equal to the coefficient of the square term on the right. So that right away tells me a must be equal to 0. Then coefficient of the x term on the left, which is 3, must be equal to the coefficient on the x term on the right, which is negative 2a plus b. So it must be the case that negative 2a plus b is equal to 3. And Similarly, the constant term on the left must be equal to the constant term on the right. So that tells me a minus b plus c must be equal to 2. We have an easy scenario here. A is 0, so if I plug in a is equal to 0 here, that gives me b is equal to 3. Very nice. And then if I plug in a is equal to 0 here, b is equal to 3 here, I get negative 3 plus c is equal to 2, or c is equal to 5. So I found a is equal to 0, b is equal to 3, and c is equal to 5. So that is technically your solution. So now if I were to rewrite it, so let's use a different color here. Let's use red. So I have 3x plus 2 over x minus 1 whole cube. The partial fraction of it is going to be, so a over x minus 1, but a is 0, so we can skip it. B over x minus 1 whole square, so b is 3, so it's going to be 3 over x minus 1 whole square, plus c is 5, so c over x minus 1 whole cube, so it's going to be 5 over x minus 1 whole cube. And that, by the way, is your final answer, the partial fraction of the given expression, 3x plus 2 divided by x minus 1 whole cube. I hope that this discussion was helpful. Thank you so very much.